Good day all, welcome to this course, Econometrics. And today we'll be dealing with chapter 1, module 1, which is Introduction to Econometrics. By way of objectives, we'll be looking at understanding the definition of econometrics, we'll be looking at learning different roles econometric plays in linking economic theory. We'll also be looking at gaining familiarity with various types of data in econometric analysis. We'll be looking at developing an understanding of basic concepts and techniques used in econometrics. We'll also be looking at equipping learners with the knowledge needed to apply econometric methods in real-world scenarios. By way of introduction, econometrics is an essential field of study in economics that applies statistical and mathematical methods to analyze and interpret economic data. It serves as the bridge between economic theory and real-world data, enabling economists to test, validate, and refine theories with empirical evidence. Econometrics combines the theoretical concepts of economics with the practical use of data, transforming abstract models into measurable and testable hypotheses. Through econometrics, we can answer real-world economics questions such as how does the change in interest rates affect investment, or what is the effect of education on income? Econometrics helps to provide accurate predictions and informed decisions based on actual data rather than relying solely on theoretical assumptions. This is the definition of economics. Like I said, combination of economics, statistics, and mathematics applied to real-world data. The estimation is to quantify relationship between variables, that is size or direction, then also carry out hypothesis testing. It's also used for what? To forecast. That means using pattern and historical data to predict future outcomes. Let's look at some of the key concepts in econometrics. The variables and controls. What's our variables? Under variables, we have two types: dependent variable and independent variable. Dependent variable is the outcome we want to explain. E.g., you want to explain spending, you want to explain income. While independent variable is the factor that is expected to influence the dependent variable, which is y, e.g., interest rate or education. While control variables, these are additional factors that also affect y, e.g., income or inflation. Why control matters is that they help isolate the effects of the main x on y, that is the independent on the dependent. Let's look at other key concepts. Let's look at parameters, estimations, and residuals. What is a parameter? A parameter, this is the true effect in the population that is unknown. The estimate, this is the effect computed from the sample data. That is, what is our best guess? Then, the predicted value, y, this is the modest prediction for y given x. Then the residual, this is the part of y that is not explained by the model. Now, why is econometrics important? It is used for policy evaluation, it is used for business strategy, it is for financing, it is for research quality. It is also used to separate strong evidence from weak or accidental patterns. Now, let's look at economic environment, what econometrics work with. Now, we have monetary policy variables. We have real economic variables. We have government policy variables. We have market variables. For monetary policy variables, this include interest rates, inflation, money supply. For real economic variables, they include employment, output, consumption, investment. For government policy variables, they include taxes, spending, regulations. For government policy, like for market variables, we have exchange rates, we have stock indices, then we have commodity prices. Then data reliability. This is measurement errors, missing data, or noise. How econometrics bridges theory and data. We have, it goes from economic theory, from ideas and assumptions, it goes to being an econometric model, becomes an equation. From equation, it becomes data, is measured. Then you do test and estimation on it, then you conclude and you give policies. This is how econometrics works generally. Now, let's look at simple linear regression model very quickly. This is an example of a simple linear regression model, where B1 is the average change in Y when X increased by 1 unit. B0, this is the baseline Y when X equals to 0. Other influences on Y that are not included in the model is the what? The E, the error term. Then let's look at an example, education and income. Income is equals to beta 0 plus BY education plus B, where B1, like I said, is return to education. That is income change per extra year of education, right? If B1 is greater than 0 and statistically significant, data supports the theory. Econometrics reports uncertainty using standard errors and confidence intervals. Let's look at multiple regression. Multiple regression is a step ahead of what? Simple regression. The difference is that they are adding controls here. Controls help to isolate the effect of interest rate on spending, like the example I gave. In this particular one, spend is equals to this. So spend is equal to BO plus B1 interest rates plus B2 income plus B2 inflation plus your econometric term, that is your error term. Control help isolate the effect of interest rates on spending. B1 becomes an all else equal effect, holding income and inflation constant. Now let's look at the ordinary least square, how we estimate the B1. This is how it does. This is the structure. OLS fits the model by minimizing squared residual, that is errors. Then large errors are penalized more heavily. OLS is common because it is simple and has strong properties under assumptions. Let's look to hypothesis testing. Does X matter? H0, no effect of X on Y in the population. Coefficient is 0. X1, X0 is called the null hypothesis. X1 is called the alternate hypothesis. That means X does affect Y. That's H1. That is the alternate. H0 is null. There's no effect of X on Y. We use t-test or p-value to decide if evidence is strong to either reject your null hypothesis, which is H0, or do not reject it. That means you are embracing your alternate hypothesis. Let's look at t-statistics, testing a coefficient. This is the equation, right? Where B1 is estimated effects from sample data. SEB1 is the uncertainty of the estimation precision. Then larger T means stronger evidence. The effect is not 0. Let's look at model evaluation, the goodness of fit. This is the equation, right? Where R2 is the share of variation in Y explained by the model. Higher R square means better fit, but does not prove causality. Combine R2 with theory, significant test, and diagnostics when you are running. Now, this is a regression example using an illustration, a diagram, right? This is year income. This is the income. This is the years of education. You can see an example here, right? This is a diagrammatic representation of what a regression is. Now let's look at some of the types of data in econometrics. We have number one, cross-sectional data. We have time series data. We have panel data. The data type determines suitable model, and common problems. We'll be looking at this in the next slides. Cross-sectional data. This is data collected at a single point in time across many individuals, firms, or countries. It is used to study the difference between units, e.g., why some households earn more. An example is 2025 survey of 1,000 households, right? The limitation is that it cannot directly show changes over time. What about time series? This is data collected for the same unit repeatedly over time, one unit. It is used for forecasting and studying economic dynamics. An example is monthly inflation, that is from 2010 to 2025. The key issue here is that autocorrelation and trends can distort results if ignored. What about panel data? This tracks the same unit across multiple periods. It combines both cross-sectional and time series data. It allows controlling for unobserved time invariant characteristics, that is for fixed effects. An example is the same spends profit from 2016 to 2025. A challenge here is that there's missing periods, there's data consistency, and there's more complex estimation. Comparing data types, let's look at the key differences. For cross-sectional, it is good for comparing units, weak for dynamics. For time series, it's good for dynamics or forecasting, but needs special diagnostics. For panel data, it captures both differences and changes. Strongest but most complex. That's the challenge, the key difference here. Choose the data type that matches your research question. Now, let's look at some problems in econometrics. Number one, we have omitted variable biases, that is missing important variables that affect Y and correlate with X. We have multicollinearity, where X variables move together, making effects hard to separate. We have heteroscedasticity, unequal error variance. We have autocorrelation, errors correlated over time. It is common in time series. Then we have measurement error, inaccurate data. Let's look at application of an example. Given interest rate and consumer spending. The hypothesis here is higher interest rates reduce consumer spending. That means it's an alternate hypothesis, H1. The dependent variable here um, is consumer spending, because consumer spending is depending on what interest rates. Why the main dependent variable here is the what interest rates, X. The controls here can be in form of income, can be inflation, unemployment. These are control variables that can affect this relationship. Decision rule: if B1 is negative and significant, evidence supports the theory. Because negative and significant, it means that interest rates, you reduce it. So if interest rates increase, consumer spending will what? Reduce, which means it's a negative relationship. So if it's negative and significant, that means this theory is supported. Now let's look at conclusion. In conclusion, econometrics play a crucial role in bridging the gap between economic theory and real-world data by providing systematic approach to testing economic models, estimating relationship between variables, and forecasting future economic conditions based on actual data. It allows economists to validate theoretical predictions, measure the strength of economic relationship, and make evidence-based decisions. By understanding the fundamental concept of econometrics, such as variables, estimation, residuals, and familiarize yourself with data types, you are better equipped to apply econometric methods to a wide range of economic studies. This strong foundation not only enhances your ability to conduct meaningful empirical research, but also set the stage for delving into advanced econometric techniques, enabling you to tackle more complex and deeper insight or draw insight from data. Then after this, you are supposed to do the assessments. Then that was it for module one. I'll see you in module two.